Hello students, good day and welcome back to this channel once again. In today's video, we are going to continue our lesson on vectors. We are going to look at how to find the magnitude and direction or bearing of a given vector. A vector is a quantity that has both magnitude and direction. A vector is a quantity that has both magnitude and direction. Now, given the vector AB, assuming this is vector AB, which has components x and then y. So this is the x component and then this is the y component. Now this vector can as well be written as xi plus yj. Now if you want to find the magnitude of this vector, then the magnitude of vector AB, which is written like this, is equal to the square root of the x component square plus the y component square. So basically this is how to find the magnitude of a vector. Now to the direction, tan theta is equal to y over x, that is the y component divided by the x component. Now since we want to find theta, the angle theta is equal to tan inverse of y over x. Now notice that this is the angle the vector makes with the x-axis. So this is the angle the vector makes with the x-axis. This is the angle the vector makes with the x-axis. Now to find the direction, we are going to take the bearing from the north, that is the positive y-axis. Now let's consider this to be our Cartesian plane. We have positive y, positive x, and then negative y. So we have 4 quadrants in all. This is the first quadrant, this is the second quadrant, this is the third quadrant, and then we also have the last one, which is the fourth quadrant. So assuming that we have our vector in the first quadrant, so this is point A and then this is point B. Then this vector is going to make an angle of theta degrees with the positive x-axis because it is found in the first quadrant. So that is the angle theta. Now to find the direction, we are going to take the bearing from the north, that is the positive y-axis. So from the north to the clockwise direction to the point where we have the vector acting along. So if you want to find the direction of this vector, because this whole angle is 90 degrees, then the direction of the vector from the north is going to be 90 minus the angle theta. So this is how to find the bearing or the direction of a given vector from the positive y-axis or from the north. Now let's take an example to clearly understand how to find the magnitude and direction of a given vector. Now let's take our first example. Given that a vector AB is equal to 3, 4, find the magnitude and direction of this vector. Given that vector AB is 3, 4, find the magnitude and direction of this vector. So we have the vector AB to be 3, 4. So the magnitude of vector AB is equal to the square root of the x component square plus the y component square. Now we have the x component to be 3 and the y component to be 4. So that is going to be the square root of 3 square plus 4 square. So that is going to be 3 square is 9, 4 square is 16, 9 plus 16 is 25. The square root of 25 is 5. So we have the magnitude of vector AB to be 5 units. Now let's find the direction. So we said that for the direction, tan theta is equal to y over x, and then theta is equal to tan inverse of y over x. We have the y component to be 4, x component to be 3. Therefore, theta is equal to tan inverse of 4 over 3. Therefore, we have theta to be equal to 53 degrees. Mind you, this is the angle the vector makes with the x-axis. Okay, so let's draw the Cartesian plane. So we have positive y, positive x, negative y, and then negative x. So for the vector AB, we have the x component to be 3. So positive 3 will be somewhere here. And then the y component is 4. So we are going to move, first of all, 3 units to the east. Okay, 3 units to the east. And then 4 units to the north. So this is 3 units to the east. And then 4 units to the north. Okay, now let me use short dashes to represent that. And this will be the vector AB. So this is point A, this is point B, and this is the vector AB. So this theta is the angle the vector makes with the positive x-axis because it is found in the first quadrant. So this is the angle the vector makes with the positive x-axis. Now to find the bearing or the direction, we are going to take the measurement from the north. That is the positive y-axis. The positive y-axis. So the direction of vector AB will be equal to, this full angle is 90 degrees. So that is 90 degrees minus 53. So minus 53 degrees. So we have the direction of vector AB to be 90 minus 53 is 37. So therefore, vector AB can be represented as the magnitude, that is 5 units, and the direction 0, 37 degrees. I think I left. So let's take our second example, example 2. If A, -1, 2, and B, x, y are points in the OXY plane such that vector BA is equal to -3, 4. Find I, the coordinate of B, II, the magnitude of vector BA, and III, the bearing of B from A. The bearing of B from A. Let's try to solve this question together. Okay, so we are given point A, that is -1, 2, and then point B to be x, y, and then we have the vector BA, which is -3, 4. Okay, now we are asked to find the coordinate of B. Okay, the coordinate of B. Now vector BA, which is the vector from point B to A, is written as A minus B. Okay, vector BA is the vector from point B to A. However, it is written as A minus B. So we have point A, that is -1, 2, minus point B, which is x, y. Don't forget that this vector is -3, 4. So let's write that here, -3, 4. Okay. Now let's simplify this expression. We have -3, 4 equals -1. Negative times x is -x. And then 2 minus y. Okay, so let's proceed with our solution. Now we are going to equate corresponding x and y components. So we have -3 equals -1 minus x. We transpose -x to the left hand side, -3 to the right hand side. So that is x equals -1 plus 3, and then we have x to be equal to 2. So this is the value of x. Now for the y component, we have 4 equals 2 minus y. We transpose -y to the left hand side, +4 to the right hand side. So that is y equals 2 minus 4, and then we have y to be equal to -2. Therefore, the coordinate of b is 2, -2. Okay, this is the coordinate of b. Now let's find the magnitude. Okay, let's find the magnitude. So let me start from here. So the magnitude of the vector BA, we say is equal to the x component square plus the y component square. Now this is equal to, we have the x component to be -3. Okay, so -3 square, and the y component is 4. So this becomes 9 plus 16, which is equal to the square root of 25. And then finally, we have our answer to be 5 units. So this is the magnitude of the vector AB. Now let's find the bearing of B from A. The bearing of B from A. Now the bearing of B from A is the same as the bearing from point A to point B. However, this vector, the vector BA, is the vector from point B to A. This is the vector from point B to A. So because of that, we need to find the negative of this vector. Okay, we need to find the negative of this vector. So the negative of this vector is vector AB, which is from A to B. So the negative vector, which is vector AB, is equal to the negative of vector BA. Okay, so negative vectors have the same magnitude, but they only differ in direction. They have different or opposite directions. So we are going to multiply -1 by the vector BA. So BA is -3, 4. So vector AB is equal to 3, -4. So this is the new vector, vector AB, 3, -4. So now we can find the bearing of B from A. The bearing of B from A. Now let's draw the Cartesian plane. We have positive x, positive y, negative x, and then negative y. Now for this vector, we are going to move 3 units along the x-axis. So that is this. And then we are also going to move 4 units to the y-axis, that is the negative y-axis. So we are going to move in this direction. So always we are going to focus on the angle theta, which is the angle the vector makes with the x-axis, depending on the quadrant. So whether the positive x-axis or the negative x-axis. Now this is in the 4th quadrant, so it's going to make an angle of theta degrees with the positive x-axis. So this is the angle theta. This is the angle theta. Now let's find the angle theta. So the angle theta, let me indicate the vector. So vector AB. So this is point A and this is point B. So we are going to find the bearing of B from A. The bearing of B from A. Now let's find theta. So we say that theta is equal to tan inverse of the y component divided by the x component. We have the y component to be -4. However, when we are finding the angle theta, we ignore all negatives. Okay, so we are going to write 4 divided by 3, and then theta is equal to 53 degrees. Now to the direction, we are going to find the bearing of B from A. So from A, that is from the positive y-axis, from the north in the clockwise direction, this is going to be the bearing. So you realize that it is 90 degrees plus the angle theta. Okay, 90 degrees plus the angle theta. We are going to measure from the north. So this is 90 degrees plus the angle theta. So the direction, or better still, the bearing of B from A is giving us the bearing of B from A is equal to 90 plus angle theta, which is equal to 90 plus 53 degrees. Therefore, 90 plus 53 is equal to 143 degrees. So this is the bearing of B from A, 143 degrees.